Hi, and good morning, everyone. I hope you're good this morning, and I hope you're all awake. My name is Barbara, and I'm from the Faroe Islands. And I'm actually a geologist and also a graphic designer. And I found out that I can use both my education in one workplace, so that's fantastic. And I'm going to tell a little bit about me or where I'm from. If you look at the screen, the first picture is where the Faroe Islands are located, between Iceland, Norway, and Scotland. I know some of you know where it is, but maybe not all. And it's 18 small islands with around 50,000 people. And if you look at the second picture, this is from this summer, from the Arctic competition, the winners who won an expedition to the Faroe Islands. And actually, the next competition will be starting in 2 months, approximately. And if you want to join, it would be, you could win an expedition to Svalbard or to northern Norway. So that would be very exciting. So you should have your eyes and ears open for that one. And this is Klaksvík, the city I live in. We actually see my house. And as you see, the Faroe Islands are full of rocks. So geologists, they are never bored in the Faroe Islands. And here you see a picture of my dog looking at some rocks in the Faroe Islands. I think we are ready to start the lesson. Today we're going to try to answer the question if the rocks are related. And if they are related, why they are so different in color, composition, and in different ways. In the end, we will maybe have a Kahoot if there's enough of participants and they want to have a small Kahoot. So keep your ears open throughout the lecture. So what is the rock cycle actually? This is a cycle that explains the transformation or change in rocks throughout the time in different environments. And as you see, it's a transformation that goes around, and I will explain in more details on each of them. I think we will start by focusing on the three main types. They are igneous rocks, or sedimentary rocks, or metamorphic rocks. And if we start with the first one, it will be the igneous rocks. These rocks can be divided into two kinds, the intrusive kind and the extrusive kind. If you imagine you have a magma chamber somewhere below the Earth's surface, full of magma, if this magma if the condition for the magma chamber would change and it would cool down, the rocks would solidify below the Earth's surface. And this would make the intrusive igneous rocks. But if this magma would find its way up to the surface, where it actually spews out like lava that you see here, then the rocks would solidify and solidify outside of the Earth's surface, and that's called the extrusive igneous rocks. So we have two kinds. And here you see some examples of where you would find them. If we look at the first picture, we have an extrusive, and this is a volcano that spews out lava. And here the rocks that would cool outside would be extrusive igneous rocks. And they're located here in the illustration. And if we look at the next one, this is an intrusive rock. That means that this one has cooled below the Earth's surface. If you look at this illustration, it's a magma chamber that cooled below, and then after some time, the layers above, they have been eroded away, and the rock that is solidified will find its way up to the surface. And that's what we see here in Mount Rushmore in the States. The third example, that is also extrusive igneous rocks. And this is from Iceland. This is Thingvellir. So here you see a mid-ocean ridge. And this is also extrusive igneous rock. And here you see an illustration of where you would find this. I'll just go back to this one. What drives this cycle is actually plate tectonics. And if you think about three examples on plate tectonics, you can imagine where two plates collide, and there will be a mountain chain, like the Himalayas, and another one will be a subduction zone, like this picture to the bottom right, where one plate goes below the other one. And this is what happens in the Pacific, the Golden Ring of Fire, where you have lots of volcanoes and trenches. And another one will be one plate that rifts apart, and that's where you get this rifting, like in Iceland, where you see it. Most of the Mid-Atlantic ridge is actually underwater, but a small part of it's on land in Iceland, and you can go and watch it actually. And then if we go a little bit more into detail into these kinds, the extrusive and the intrusive. If you look at the extrusive first, you see that it has a lot finer grains than the intrusive, and that's because when the rock is spewing out of a volcano, it solidifies very fast. So the grains, they don't have time to grow really large. So that's why the extrusive rock has very fine grains. If you then look on the intrusive rock, this is a very coarse-grained rock, and that's because usually the lava, the magma that solidifies and cools down, it takes a long time. So the grains in the rock, they can grow a lot larger than they can when it's extrusive. So if you zoom in, it would look something like this. You will see the grains, how they have grown together, and in the extrusive rock, you wouldn't see the grains that obvious, at least. And here are some examples of igneous rock, the extrusive kinds. This is granite and gabbro and diorite, and these all have very clearly different kinds of grains growing in them. And if you look at these rocks, they actually have an equivalent that's exactly the same rock that you see here, but this one has been solidified with outside of the Earth's surface. So this one has the fine grain. So as you see, these are actually the same rocks, but it looks totally different. Depends on where they have solidified. So this is how you see the difference between the extrusive and the intrusive. Then we can go to the next sediment. This is the sedimentary rocks. I just have to find my notes. This is different processes that when you have a sedimentary rock, that actually means that it's other rocks that have been eroded, for example, by wind and water and ice, and they sort of break down. If you imagine you have a mountain chain here, and the weathering and erosion breaks down these rocks into very small fragments, and these fragments can then be transported by, for example, a stream that takes them out to the sea that you see here. And when they finally get out of the sea, it will eventually settle down, and the compaction starts afterwards. I have a slide that shows if you imagine the stream coming out here on the left and going into the ocean, and then as time goes, more and more of these grains will come on top of the other ones. If you look at the top layer, it has a lot of water in between the grains. So it's a very loose pack, and it's not very lithified yet. But if you start going down, where the pressure also increases, the pressure will cause the water to be squeezed out from these holes between the grains, and the rock will become tighter. And if you go all the way to the bottom, it will become even tighter. And this is when the grains can lithify together. And that's when they actually become the Igneous happens, and it's a sedimentary rocks. So it contains of other rock fragments, actually. Here you see on the left, we have the clastic rocks. This is the one that I showed you that were solidified in the bottom of the sea. We have a shale, and we also have a breccia. That's another kind where they have bigger rock fragments that are more angular. But on the left side, we have the second kind of sedimentary rock. It's either clastic or non-clastic. And the non-clastic, that means that they have been having a chemical reaction. So, for example, if you have a limestone and water runs through it, then you would dissolve some of the minerals, and then you will get like these stalactite and stalagmite stones. So these are chemical reactions, and on the left, these are rocks made of other small rock fragments. So those are the main types in the sedimentary rocks. And then if we go to the The next one, this is the metamorphic rock. This will explain how the metamorphism happens. If you look at this chart, we have a x-axis with increasing temperature. So if you go this way, you have high temperature and a low pressure, so you get some kinds of rock. I'll show you in a little bit. But if you go this way, you have increasing pressure, but you don't have that high temperature. This creates another kind of rock. And then if you go in the middle, it's a third kind. So, and if you look at where this happens, if you take the first, the green arrow, this is sort of that this happens with the subduction zones that I told you about, where one plate goes below the other one. And if you look at the top, the yellow arrow, this is where you have a volcano, maybe, where this happens. And if you look at the middle one, this is where you have a continent, where you have away from the plate boundary, so you have a more stable, large continent. And you see I put a diamond here. That's because those are made in extreme high temperature and extreme high pressure. So those are not so normal, and it doesn't happen all over. It's just some specific places. Here you see the same chart actually, but just with a few rocks where you have the names, and I also have a picture of the rock. So if you go in the first one here, this is the zeolites. These form very easily. If you walk out into nature, you can see these in a lot of rocks, and you can find these almost anywhere. But if you look at the green schists and the blue schist, and if you go all the way down to the eclogite, this is a very dense rock, and this is not one that's very common. It's not one that you find easily. It's made very far down in the mantle, and when it gets, it only comes up if there's a volcano or something that spews it up. And on the other side, you see also different kinds. You see hornfels and amphibolite and granulite. So these are all different types of metamorph rock. And if you think about the metamorph rock, the word metamorph, that means actually change in form. So this is when a rock is, if you look at this, the protolites, these are the original rocks. These are actually a sandstone. If you find a sandstone and it's been exposed to metamorphism, you actually will find a quartzite. And if you look at another rock that's, for example, shale, then you will metamorphize into slate. And if you have another rock, limestone, for example, it will metamorphose into marble. So these are very different kinds of metamorphism. If you look at the chart here, I'll go in the back for a moment. If you look at this chart, you can actually do it in a second again, it'll come up again in a volcano, and then it goes around. So this process that I told you about, the plate tectonics, this is a really slow process. It takes millions of years for all of the small changes to happen. And I go down here again. Yeah, so here you actually see the chart where it goes all the way around. You have the magma chamber where it comes up into a volcano, and you also have rocks that have been uplifted and exposed. And when they're being wetted, they go round again, and they get to sedimentary rocks, which again are buried and go low, a long way below the surface, where they happen to metamorph again, and the metamorph rock goes into the melting again. And this is how the rock cycle actually goes round and round. This is it's a short lecture, I think. Maybe I was going a bit too fast. But if you have any question, please write to us in the chat. And if you want me to explain some of these a little bit more, just let me know in the chat. I think I can see the chat maybe.